Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with the problem set from lesson 519, and these are the answers. All right, let's get started. Number one, Dante built a wooden cubic toy box for his son. Each side of the box measures 2 feet. Part A, how many square feet of wood did he use to build the box? Well, I know that each side is 2 feet, so 2 feet times 2 feet will be the area of each side, and I know there are going to be 6 sides. So 2 times 2 is 4, times 6 is 24. So it's 24 square feet is the surface area. And then the question is, how many cubic feet of toys will the box hold? Well, the box is, this is volume, so the box is a 2 foot by 2 foot by 2 foot. 2 times 2 is 4, and 4 times 2 is 8, so it will hold 8 cubic feet of toys. There's number one. Number two, a company that manufactures gift boxes wants to know how many different size boxes having a volume of 50 cubic centimeters it can make if the dimensions must be whole centimeters. List all the possible whole number dimensions for the box. Well, we're going to just have to think these through. We got to multiply up to be 50. So I know that 1 times 50, that will work. And 1 times 2 times 25 will work. Let's see, 1 times 3 won't work. 4 won't work. 5 will work. 1 times 5 is 5, and then multiply that by 10. That's 50. And then I think that's it. 50 is, that's about it. So those are my 3 possibilities. Which possibility requires the least amount of material to make? Well, I would need the surface area of all of these, and I remember from our lesson that the one that's closest to a cube would be the least amount of surface area. Let me just think here. 2 times. What if we did this? 2 times 5 times 5. That would work, right? 2 times 5 times 5. Yeah, 25 times 2, that's 50. So I guess there is another one. And in fact, that's the one I want. That's going to be the least amount of surface area because it's closest to a cube. All of my dimensions are as close together as possible. And so that will be it. It's a 2 by 5 by 5 will be the least amount of material. All right, number 3. Rectangular box of rice is shown. What is the greatest amount of rice in cubic inches the box can hold? This is volume. So volume equals the length, 15 1/3, times the width, 7 2/3, times the height, 6 1/3. So what we're going to do here is we're going to change these mixed numbers into improper fractions. 3 times 15 is 45, plus 1 is 46 thirds, times, let's see, this is 21 plus 2 is 23 thirds, times, let's see, this is going to be 18 plus 1 is 19 thirds. And let's see, I don't think I can simplify at all before I multiply, so I'm just going to multiply. 46 times 23 times 19 equals 20,102 over 3 times 3 is 9, and 9 times 3 is 27, and that is cubic inches for volume. 20,102 27ths cubic inches. That's my answer. Number 4, the Mars Cereal Company has 2 different cereal boxes for Mars cereal. The large box is 8 by 11 by 3 inches deep. The small box is 6 by 10 by 2.5 inches deep. How much more cardboard is needed to make the large box than the small box? Well, first we have to find surface area of both. So let's do the large box over here. The large box is going to have a, let's do front, back. It's going to have a top and a bottom, and it's going to have a left side and a right side. Front and back are going to be the same. The top and bottom will be the same. The left and the right will be the same. And let's see, let's go 8 by 11, and there's 2 of those. And then we're going to have an 8 by 3, and there's 2 of those. And then we're going to have an 11 by 3, and there's 2 of those. So 8 times 11 is 88, times 2 is 176, so we've got 176. 8 times 3 is 24, and 24 times 2 is 48, so we'll have that for the top and bottom. 11 times 3 is 33, times 2 is 66, so that is the right and the left side. Add those together, and we get 20, carry the 2, that's 13, 19, carry the 1, and that's a 2. So 290 square inches for the the large box. And then if we do the small box, we'll put that one over here. The small box also front, back, together, top and bottom together, and a right side and a left side together. And let's see, the small one is a 6 times 10 times 2 for the front and the back, a 6 times 2.5 times 2 for the top and the bottom, and a 10 times 2.5 times 2. That will be the right and the left side. So 6 times 10 is 60, times 2 is 120. And then we have a 6 times 2 is 12, and then 12 times 2.5 is 30. That's the top and the bottom. And a 10 times 2 is 20, so 20 times 2.5 is 50. That's the right and the left side. And if I add those together, I get 200. So 200 square inches is the surface area of the small box. So then to find out what the difference is, we would just subtract 290 minus 200, 290 minus 200, and the difference is 90 square inches is how much bigger the big box is than the small box. That's part A. Part B, how much more cereal does the large box hold than the small? Well, we've got to find the volume of the large. So the volume of the large box is an 8 times 11 times 3. 8 times 11 is 88, and 88 times 3 is 264. So that's 264 cubic inches for the large box. And then if we do the small, the volume of the small box is going to be a 6 by 10 by 2.5. And if we multiply those, 6 times 10 is 60, times 2.5 is 150. So the volume equals 150 cubic inches for the small box. And when you subtract 264 minus 150, you get 114 cubic inches is how much bigger the large box is than the small box in volume. There's number 4. All right, number 5, a swimming pool is 8 meters long by 6 meters wide by 2 meters deep. The water-resistant paint needed for the pool costs $6 per square meter. How much will it cost to paint the pool? Well, this is surface area, and since it's a pool, we'll have no top. So I'm going to go front and back. I'm going to have a bottom, but no top. I will have a right side and a left side. So front and back, let's see, we'll have if it's 8 meters long and 6 meters wide and 2 meters deep, let's draw this a little bit. 2 meters deep is going to be about like that. And so I'll just sketch this quick so we can see it. So here's our pool. It's going to be 8 meters long. It's 6 meters wide, that's here, and it's 2 meters deep. So that one's there. So we're going to have the front and the back is going to be an 8 by 2. So that's 8 times 2 times 2. The bottom will be an 8 by 6. That's here. 8 by 6. So no top, so just 8 by 6. And then the right side is a 6 times 2. So 6 times 2, and then another times 2 to make sure we count the left side as well. 16 times 2 is 32. 8 times 6 is 48. And then 6 times 2 is 12, and 12 times 2 is 24. So add those all together, and we get a 14, carry the 1. That's 104 square meters will be what we need to paint. Now, it says that it's $6 per square meter, so I'm going to take that 104 square meters, and I'm going to multiply that times 6 to get the cost to paint the pool. 6 times 4 is 24, carry that 2, that's a 2, and 6 times 1 is 6. So $624 to paint the pool inside. Part B, how much paint in square meters do you need? We did that, 104 square meters. How much will it cost? We did that, $624. Got it. Part A, how many faces of the pool? 5, because there's no top. All right, moving on. Number 6, Sam's in charge of filling a rectangular hole with cement. The hole is 9 feet long, 3 feet wide, 2 feet deep. How much cement will he need? That's volume. So we're going to fill a three-dimensional space. That's volume. It's 9 feet times 3 feet times 2 feet. And 3 times 2 is 6, and 6 times 9 is 54. So this is 54 cubic feet to fill that rectangular prism. All right, and lastly, number 7, the volume of box D subtracted from the volume of box C is 23.14 cubic centimeters. Box D has a volume of 10.115 cubic centimeters. So we've got to find, when we subtract the two volumes, we've got to find the difference to be this. So if box D has a volume of 10.115, I could say that box D subtracted from the volume of box C. So we're going to go box C minus box D is going to equal 23.14 cubic centimeters. And they told me what the volume of box D was, so I'm going to substitute that. I'm going to say that C minus box D, which they told me was 10.115, is equal to 23.14. And then I can use algebra to isolate C by adding 10.115 to both sides, 10.115 to both sides. That will give me box C. C is equal to, let's see, this is a 5 and a 5 and a 2, and this is a 3 and a 3. So box C has to be 33.255 cubic centimeters. So there's my equation. I've solved it, and that is box C. Now, part C, the volume of box C, is 1/10 the volume of another box, box E. So E represents the volume of box E in cubic centimeters. Write an equation that could be used to determine the volume of box E. Well, box E equals 10 times box C. 10 times box C. So I can say that E is equal to 10 times 33.255. And 10 times 33.255 means that box E is equal to 332.55 cubic centimeters. So centimeters cubed. All right, and there it is. That is those are the answers to the problem set for lesson 19. Hope that helps. See you again next time.